Flack math! Give me some math and I'll give you some flack. Flack math!
So 75 is more on ratios. So when we talk about ratios, the first thing that should come to your mind is tic-tac-toe, right? And then we have like our ratio column, like a, not ration. So if we have boys and girls, and then we have this last row, which is total. So if the ratio of boys to girls is like 3 to 5, then our total would be 8. And let's say like there's, I don't know, 24 students, and I want to know how many girls that is, then that would be, okay, fish method, 5 times 24 divided by 8, or 8 times 3 is 24, so 5 times 3 is 15 girls, okay? So that tic-tac-toe method makes it real easy. So this works with pretty much everything, even fractions and weirdness, so you can fish method whatever you want. My voice just cracked there. So you can fish method whatever you want. Let me just mark Michaela here.
Hey, Mr. Flack.
Hi.
Where are all the others?
Well, I think Austin is stuck in Steamboat or something.
Oh.
But I'm not sure where Emerson or Ben are. But let's keep going with this here. So we're talking about ratios. So here's example 1 on lesson 75. Example 1 says it takes 2.5 eggs to make 140 cookies. Okay, so let's say we're making cookies. It takes 2.5 eggs to make 140 cookies. So Jenny wants to make 1,680 cookies. So how many eggs? Well, you don't have to do any kind of math. You just have to tic-tac-toe, right? 1680 cookies. So let's just set up a ratio box. So 2.5 eggs for 140 cookies. So if this is my ratio, and this is my eggs, this is my cookies, and this is my total, we don't really need this row on this problem. So let's just do this. 2.5 eggs for 140 cookies. So I want to know how many eggs for 1,680 cookies. So here's my proportion right here. That's nice. So I'm just going to fish method that. So we're going to go 1680 times 2.5 and then divide it by 140. That's the fish method, right? Everybody good with that? So how do you multiply by a mixed number? Xavier, how do you multiply by mixed numbers? You don't. I think that's what he was going to say. So that's what we're going to do. 1680 times 5 halves divided by 140 over 1, or what we're going to do is we're going to multiply by 1/140th. All right, so let's do that. I'm going to just make this a little simpler here. And this is, remember, I'm going to go times 1 over 140 because I'm going to copy dot flop that. So this 2 and the 1680 becomes 840. And then look at this. I can do this here too. So this will be like what goes into both 140 and 840. Well, what is that? Well, 140 I think goes into 840 6 times. Yeah, so 1 and 6. So then my answer is 6. Is that right? Doesn't seem right. Is that right? Doesn't seem right. 6 times 14. So 6 eggs for that many? Is that right? Let's see what we got here. do it? Did we do it? So 140 cookies. Did we write that down right? Yeah, that's right. So 5 halves. Oh, we forgot to multiply by 5. Yeah, that 5 there. So 6 times 5 is 30. So 30 eggs. That makes sense. 2.5 eggs for 140 cookies. How many? 30 eggs. So all we did was fish method that. All right, let's do example 2. Example 2 says this. It takes 3 tons of fertilizer. So we're going to do tons of fertilizer. So this is still the ratio column. And so we're going to go fertilizer for one of the rows. So 3 tons of fertilizer to make 100 for 170 acres. So this is going to be acres. All right. So 3 tons for 170 acres. Okay. Farmer Brown wants to fertilize 1,870 acres. So that's where it goes in the acres column. So now what we're going to, or the row, so now we're going to fish method that. No problem. 1870 times 3, all divided by 170, right? That's the fish method. So when I do that, I get 33. So 33 tons. That's pretty simple, right? That's just fish method. You just got to, when you don't know, tic-tac-toe. No problem, okay? That's lesson 75. So we're going to move on to lesson 76. So this is multiplying in scientific notation. We already talked about scientific notation a little bit. So here is lesson 76. So multiply in SINOT, scientific notation. Okay. So let's just do a little bit of review. If I wanted to put this number into scientific notation, how would I do that? Well, let's have a look here. So remember, the first step to scientific notation, steps to SINOT. SINOT is first step, put decimal after first non-zero digit. After first non-zero digit. So the first step, I'm going to go 4.396. Okay. Second step is I got to move this decimal. I got to make this equal to that. So what power of 10 do I have to multiply by this to equal that? Well, what will put this decimal 3 places to the right to get it back to there? 10 to the third. So step 2 is multiply by power of 10. That will return the decimal back to its starting place. Return decimal, and starting place is origin. So return decimal back to origin or original place, right? So we got to move it 3 places to the right. So we need a 10 to the positive 3. So that's just a little review on SINOT. Okay, so now we're going to multiply in scientific notation. This is the whole point of scientific notation, because scientific notation allows you to multiply 2 numbers that are in between 1 and 10. That's pretty doable, right? And then you can multiply the powers of 10 easily by just adding the exponents. Okay, so let's just try example 1. Example 1 looks like this. 4 times 10 to the 5th. I'm going to multiply this number times 2 times 10 to the negative 2nd. Okay? Well, this is just multiplying 4 things together. Do you see it? It's 1, 2, 3, 4. So what I'm going to do is I'm going to just multiply the 4 and 2 together. That's 8, right? And now I'm going to multiply 10 to the 5th times 10 to the negative 2. Do you remember what you do with the exponents when you multiply powers of 10? You just add them. So this is your final answer. That's why this is so much better than otherwise I would have had to multiply these two numbers. 400,000 times 0.02. I would have had to multiply these two things together, which isn't terrible, but it's kind of annoying, right? All right, guys. I know traffic is probably crazy today and it was hard for you to get to class, but you're like 15 minutes late in getting to class. So,
yeah, my bad.
all right. So, Xavier, what are you doing? You're like singing at the top of his lungs. Can you hear me? Maybe not. So I don't know if he's listening to me. He's probably listening to music because he's like singing at the top of his lungs. But that's okay. We're going to move on. He can watch the video later. All right. So we are back to here. So multiplying in scientific notation, basically you multiply the big numbers, the normal numbers, and you multiply the powers of 10. Multiplying powers of 10 is easy because all you do is add the exponents. I'm going to show you another example. Like when you multiply powers of 10 together, well, what is 10 to the third? That's just 10. That's just 10 times 10 times 10, right? Well, what's 10 to the second? That's just 10 times 10. Well, what's an easier way to say 10 times 10 times 10 times 10 times 10? This is just 10 to the fifth. Okay, so all you're doing is adding. You're not adding powers of 10. You're just counting how many total times you're multiplying a power of 10. So 10 to the third times 10 to the second. So that's 10, 10, 10, 10, 10, 10 to the fifth. Okay, so all you do is add the exponents even when you have negative numbers. So instead of 10 to the fifth time, so in 10 to the fifth times 10 to the negative second, just add the exponents. 5 plus negative 2 is 3. Okay. All right, let's do another example. Here is example 2, and then we'll be done for the day. So Ben and whoever else showed up late, don't forget to watch the video online. So this is our next one.
Okay.
3 times 10 to the 8th, all times 3 times 10 to the third. I lied. There's one more example after this. All right, see if you can do this by yourself. See what you get. Okay, so hopefully you're done by now, but if not, let's just do it together. So remember, you can multiply these in any order you want. So I'm going to multiply the 3 times 3 first and get 9. And then I'm going to multiply 10 to the 8th times 10 to the third. Do you remember what you do there? Well, you're multiplying 10 8 times and then 10 3 more times. So how many 10s are you multiplying? 11.
11.
So, nice. So there's your final answer. That works. That's nice, right? Okay, the only time this is going to get tricky is this next one. So if you can understand example 3, you're good to go, okay? So here's what example 3 says. 4 times 10 to the negative 6, all times 6.2 times 10 to the fourth. Okay, well, let's just do that. Let's, I'm going to pull up my calculator here. I'm going to multiply 6.2 times 4, and I get, what do I get? 24.8. Okay, so 24.8. And then let's multiply our powers of 10. Let's see, 10 to the negative 6 times 10 to the fourth. So add the exponents, and you get 10 to the negative 2. All right, now at first glance, this looks like it would be the right answer, the final answer. But what's wrong with this answer? Can you guys see what's wrong with this answer?
No.
This is not scientific notation. Do you see why it's not? Because look,
Oh yeah, the decimal is not after the first
right.
non-zero
So we're going to
number.
fix that. So how do you put the decimal after? So let's put it in scientific notation. Remember, put the decimal after the first non-zero digit, and then we multiply by a power of 10 that will return it back to here.
2.48 times 10 to the negative third.
Well, look, let's do this first. So to move it back here, I need to move it 1 to the right, right?
Maybe -1 instead because you're taking 1 away from the 2.
No, because we have to go back to this. So remember, you're thinking backwards, okay? But yeah, your final answer, Henry, is -1. Because look at this. Now I've got all this, but it's 10 to the first, all still times 10 to the -2. So now I add the exponents. So my final answer is 2.48 times 10 to the -1. Good. So that's the only kind of cleanup you do, because sometimes when you multiply these two normal numbers, you end up with a number that's not in between 1 and 10. You end up with 2 digits before the decimal instead of 1 digit. So if that's the case, then you just have to add another power of 10, put the decimal in the right place, add another power of 10, and then call it good. Okay? So that's about as complicated as it will get. Don't worry about it. Let's do one more, see if you can do it. Give me a final answer. This is this is example 4, which is not in the book. Let's just try it. So 3 times 10 to the 8th, all times 4 times 10 to the -6. So see if you can do that. Take a minute. See if you can give me the final answer in scientific notation.
Is it 2.4 times 10 to the second power?
No. I don't know how you got 2.4. Are you looking at the same problem I am? Are you realizing your mistake?
Yeah, I just multiplied by the wrong number.
Yeah, so instead of, this would be 12, right? And this would be 10 to the second, right? But the problem with this is this needs to be fixed. So what do we do? So how do you say 12 in scientific notation? I know it's kind of a pain, but how do you say 12 in scientific notation? Put the decimal after the first non-zero digit, so 1.2 times 10 to the, basically, you have to move it 1 to the right to equal that. So 1. So now you can combine those. So final answer, 1.2 times 10 to the third. Is this doable, guys? Can you handle this?
Yep.
Okay.
Yeah.
Black math, give me some math and I'll give you some flack. Black